Okay, so a static data structure is a data structure, so it's a place where you're going to store lots of data, and it's defined by the programmer. The key thing about static data structure is the size of the structure is fixed. So once it's created, that size of that data structure is fixed, and you can't change it. You can create a new data structure and move things into it, etc., but you're not changing the data structure. The data structure is fixed. Because it's fixed, let's say I've got a data structure that's 10 items long, it usually, almost always, allocates sequential memory locations. So it will find a piece of memory that's 10 locations long and allocate that to your data structure that you want. So they often use a single start pointer to tell you where memory begins, and they might have an end pointer as well. Okay, but they don't use lots of pointers. If they do, they just use one or two. So they might have a start pointer and an end pointer, so you know where it starts and where it ends. Therefore, you can define it, work out the length, that sort of thing. So an example could be this. So you could say Dave, Sally, Robert, and Chris, and you could say that could have been a fixed length of 4, and that could be stored, as we know, stored in RAM. But it's thinking about how data like this might look inside the RAM. So, and then how you can do some of the more common things on it. So let's say here we've got a static data structure that's 6 items long. It's got in memory location 1, it's got 6, memory location 2, it's got 5, and it's got start pointer 1 and currently a rear pointer 2. I know I can only go up to 6 because it's static. So adding to the static data structure is simply a case of adding a piece of data in the next available memory location and then increasing the rear pointer by 1. And then I've added a new piece of data into my static data structure, and that's all I've had to change. Okay, so that start pointer and rear pointer obviously might not be 1 and 3. It depends on what the memory locations are, but the concept is this. Okay, and you need to understand what a static data structure is and how you would do some of the basic commands to it. So that's adding, removing from the data structure. Okay, we'll do it this way around. So sorry, I've done it a different way around this. So it depends where you're removing the data from, but you most likely have to shuffle data down the structure and decrease the rear pointer. Okay, so what I've done here, I haven't shuffled data down. It depends if you're deleting from the front. So let's say this is my current state of affairs, this data structure here. And let's say I want to remove the last item. So currently the start pointer is 1 and the rear pointer is 4. If I'm going to remove item 3, all I do is change the rear pointer to be 3, and then that is no longer used, that memory location. I don't actually delete the contents of that memory location. The way things get deleted in computers is typically they get overwritten. So the next time that memory location is used, it will overwrite what's in it. Because I'm not using it anymore based on the pointers, I have essentially deleted it by simply never referring to it. Okay, but the reason we don't actually delete data is because if you imagine it's just ones and zeros, if you change a 1 to a 0, it's still data. So you don't delete it because it's a waste of time. All right, it's a waste of the computer's time. It's quicker to not delete it and just overwrite it the next time you need that memory location. But obviously, if there's stuff in there, the memory location won't ever get overwritten unless you tell it to. So that's an example of how you'd remove. You just remove the piece of data and change the pointer down. If, say, we're removing the number 6 from the front, okay, what would have to happen is the pointers would still have to change like that. Because it's a static data structure, what would happen is they would typically shuffle down. So 5 would go into that memory location, 14 would go into that one, and 3 would go into that one. Okay, and then 6 would have been removed, but the pointers would need to say that because there'd only be 3 items left. Okay, so that's how you remove from a static data structure. And inserting into a static data structure. So this means moving memory location of other items so you can fit a new item in the correct position. This could be a lot of work if it's a large structure. If this structure was 1,000 items long and I want to insert position 2, I might have to move a hell of a lot of data. And we'd also need to increase the rear pointer. So let's say here we've got a start pointer of 1, rear pointer of 3. Our same one's in. We want to insert the number 3 at position 2. What we need to do is shuffle 14 back to what's in memory location 3 back to 4, what's in 2 back to 3, insert our new item into position 2 where we wanted it, and increase the rear pointer to 4 because that's now included in the data structure. And that's how you insert into the static data structure. When you're inserting or adding is probably a better example. When we're adding, there would be a check when you first add an item to check it's not full. So to check the rear pointer isn't pointing at the length of, 1 plus, if we know it's 10 items long, or this is 6, it's not pointing at 1 plus the length. So there is a check to check it's not already full, because you can't add in to data where you've already used all the memory locations.